In this lesson, we're going to plot and solve one variable inequalities. And so one of the things we need to do is know the difference between an and an or. An and inequality, that's going to be the intersection of the solution. So if I have two possible values for x, the and will be where they cross or where they intersect and overlap. If it's an or, that's going to be all the solutions of one combined with all the solutions of the other. So that's going to be an or. Now, when we plot these things, we've got to be careful of the way the dot looks. So if I have an inequality symbol and it's got one of the equal to lines in it so that it's actually equal to a point, then we need to show that that point is actually a solution by closing the whole dot in. It's going to be a solid dot. However, if the inequality actually is just a less than or greater than, the point itself will not be a part of the solution. And we show that by having an open dot when we draw it on the number line. It'll just be an open circle. Okay, so let's work a couple examples here to see how this is going to work. And what we have is let's say these would be the answers to an inequality. I would have x greater than or equal to a negative 2 and x less than 5. Now I'm going to draw the lines underneath the number line because this is going to be an intersection. It's an and I want to show the crossing itself on the number line. So this is the way I'm going to do this. I'm going to say x is greater than or equal to a negative 2. So here's a negative 2, and notice it's got an equal to, so it's going to be a closed dot, and it's greater than a negative 2, so it's going to be going in this direction. For the x is less than 5, that would be an open dot at 5, because 5 is not actually part of the solution, and it's all the values that are less than 5. So my actual answer will be the overlap, because it's an intersection. So the actual answer will have a closed dot here at a negative 2 with an open dot at 5, and it will be all the points in between, showing that it's the intersection of those two solutions. Okay, let's take a look at an or. So I use the same numbers so you can see the differences in how these graphs will look. So x is greater than a negative 2. Well, we know what that is. It's going to have a solid dot here at a negative 2, and it's going to be all the values that are greater. And on the other one, of course, we have a open dot at 5 and all the values that are less than. That's for the x is less than 5. Now, what we have is this is an or. So it's all the solutions of the one graph and combined with all the solutions of the other graph. And what you can see that the line right here where it says x is greater than or equal to negative 2 is going to go out for all getting greater and greater and greater, and it's going to pass right over that open dot. And since it's the combination, this answer is actually going to be all points on the number line. So that would be the actual solution because I combined the two answers. Okay, let's go down to the next one. And we have another and this time we have x is less than or equal to a negative 2. So down here to negative 2, closed dot, all values less than. And over on the other side, we have x is greater than 5, so that would be an open dot, all values going this way. And it's the overlap of the two lines, and there is no overlap. So this would be one where the actual solution, where they cross, there isn't any, so this is a no solution. And for the last example, we have x is less than or equal to a negative 2. That would be a closed dot going this way to the left. X greater than 5 is an open dot going to the right. And now it's the combination of the two. So it would be all the solutions of the one line and all the solutions of the other line. So the actual answer on the number line would look like that. Okay, now let's actually solve some inequality equations. So what we need to do when we solve these is we need to get this set up so that it's going to say y is equal to x or equal to whatever the variable is. We want it on one side, and what it equals to is on the other side. And so we're going to isolate the variable just like we did if we were solving a problem that had an equal to sign. The one additional thing we have to do is if we divide or multiply either side by a negative number, what you do to one side, you do to the other side. So if I divide or multiply by a negative number, I need to switch the symbol. Like, for example, this one would switch from a less than to a greater than. So let's see how all this works. So in the first problem, I need to get this y alone, so I'm going to add an 8 to both sides. So if I add 8 to both sides, my problem will now be a minus 5y is less than 20. Now, I didn't divide or multiply by a negative number, so the inequality symbol stays a less than. But right here in this step, I'm going to divide by a negative 5. And that's going to give me on the left side, I have a y, and on the other side, I have a negative 4. But because I divided by negative 5, that inequality is going to have to switch its direction. And so my final answer is going to be y is greater than a negative 4. And how that will work when we graph it is I'm going to put a, notice that there's no equal to sign. So here at a negative 4, I'm going to put a open dot and all the values of y that are greater than a negative 4, so that will go out to the right. Next one, we're going to get the x alone. Now, because I don't want to really have a negative x, that just adds a different, an extra step. I'm going to start off by saying, okay, I have a 2x and a 6x. And if I wanted to keep the x positive, I would subtract the 2x from both sides. And that would give me 1 is less than or equal to 4x minus 1. Okay, now let's take care of the moving this negative 1 across. So I would add 1 to both sides. And I would have 2 is less than or equal to 4x. Lastly, I'm going to divide by 4. So I get 1/2 is less than or equal to x. Now, I didn't divide or multiply by a negative number, so the inequality sign does not switch. So x is less than or equal to 1/2. That would be 1/2 would be right there. And all the values less than or equal to would be going out to the left. In this last group of problems, I have compound inequalities. That means that there are two actual equations that we're going to use, or at least two equations we're going to have to use in each problem. Now, these first two problems are written slightly differently, but they're actually the same one. We have this negative 2 is less than or equal to 3t, and. So this is going to be an and. The answers are going to be the intersection. And another way to write that is, notice over here on the left, I have a negative 2 is less than or equal to 3t minus 8, but then I have this same 3t minus 8 being less than or equal to 10. And this is a shortcut way of showing an and. It's showing that what's in the center has to satisfy both of those things at the same time. So that's a shortcut way. If you ever see it written like this, it's the same thing as an and. And we're going to work it both ways so you can see how to do it. Let's start with the one over on the right first. And so I'm going to solve the left side first. So I'm going to divide both sides by 3. And if I divide both sides by 3, I get a negative 2/3 is less than or equal to t. Now it's an and. And let's go ahead and solve this other side. So I'm going to add 8 to both sides. So I've got 3t is less than or equal to 18. Divide by 3. I would get t is less than or equal to 6. I did not divide by any negative number, so none of the inequality signs flip. So that's my answer to that side. Now, if I have this shortcut way, this is what I can do. Actually, I left something off this. Sorry. So I have to go back and redo it. So let me redo this side real quick. I left the -8 off that side. So the first thing I'm going to do is I will add 8 to this side on the left. So if I add 8, I get 6 is less than or equal to 3t. And then dividing by 3, I get 2 is less than or equal to t. Don't forget these are ands. T is less than or equal to 6. Okay, going over to this other side. Now, what's good about this abbreviated way of writing an and is that what I can do is I could say, okay, in the middle here I have a -8. That's where my t is, my variable. So I'm going to add 8 to the middle. But I'm also going to add it to each of the other sides too. If I do it to the middle, I have to do it to the other two sides. And so when I add that, this side will be 6. And this right side will be 18. Now let's divide to 3. So I divide every side by 3. And I'm going to get 2 is less than or equal to t is less than or equal to 6. So this says that t is greater than or equal to 2, and at the same time t is less than or equal to 6. So sometimes this one's even a little bit easier to see how to plot it. So that means at 2, I'm going to have a closed dot, and all the values where t is greater than 2. So that would be, here's 2, closed dot, t is greater than 2, and t is less than or equal to 6. Let's put a 6 on the line. So that would be all the values where t is less than or equal to 6. That would be a closed dot going this way. And so the intersection of the two would be all the points in between. Let's move to the OR. So for the OR, that's going to be the combination of the two answers. So what I have is okay, now that I've corrected and added the part of the problem here, let's go ahead and solve it. So what we want to do is on the left side, we want to get the x alone. So I'm going to subtract 3 from both sides. So if I subtract a 3 from both sides, I would have 2x is less than 2. Or, now on the other side of the equation, I'm going to add or subtract 7 from both sides. So if I subtract a 7, I would have a minus 4x is less than a negative 16. For this left side, now I need to get the x alone. I'll divide both sides by 2. I'm not dividing anything by a negative yet, so I would have x is less than 1. And on the other side, I'm going to divide by a negative 4. Now when I do that, of course, I'm going to have to switch the inequality sign. So negative 4 divided by a negative 4 is 1. So I have x, and the inequality sign flips, is greater than 1. Okay, so this is going to be kind of a funny looking graph. So what we're going to have is we're going to have all values where x is less than 1. So here's 1, and all the values less than, it's going to be a circle. And all the values where x is going less than would go this way. And then for the x is greater than 1, now that would be the combination of both of those. And notice that the only point that's not going to be covered when I move them up to the line is going to be the number 1. It's going to be an open dot, and all the values going out to the left and right. So what you can see is really the combined answer is going to be all the points on my number line except for the positive one itself, which has an open dot there. That's it.